Welcome to Learning to Engineer. In this video, we will solve a problem to understand Kirchhoff's current law. Click the link in the description to know some small problems in KCL so that we can understand KCL and then solve this problem. Let's get started. Yeah, just bear with this drawing. I just drew it in a hurry. It will not look as neat as you see in this picture. Okay, so in this network, we happen to see that there are so many nodes here actually. So we may feel that we should apply KCL in all these nodes. It's not necessary. We can actually reduce this into two node circuit. Let me show you how. Between these two ends, there is nothing connected. Between these two ends, there is nothing connected, and similarly for all these ends. So everything can be reduced into one single node. Let me call this as B and this as A. To understand the scenario better, you can imagine that you have two airports. The center one is one airport and all the other corners are one airport with different gates. Even though you have different gates, it's just the same airport. Like that, in the corner nodes, even though you have different nodes, but they are all connected together into one single node because they don't have any elements connected between them. The node at one end is same as the node at the other end. Therefore, all the corners are just one single node. You can imagine a flight traveling between one airport to the other. This is just like the current that travels between one node to the other. Between B and A, we have all these elements connected. This is A and this is B. From B to A, IY is traveling. IY is traveling into A. So therefore, this is my IY. Okay, this is my IY. IX travels from A to this node which is same as B. IX is traveling into B. Similarly, 5 is traveling into A. Three ampere is traveling into B. Therefore, this is 3 ampere which is going right into B. Next we have IZ. I am drawing IZ in the left because I don't have space in the right. IZ is traveling into A. So now we have reduced the circuit into two node circuit so that it becomes easy for us to apply KCL. Because we know at which node the current is exactly entering and at which node the current is exactly leaving. According to KCL, what are entering? According to KCL, IZ is entering, IY is entering, 5 ampere is entering and IX and 3 ampere is leaving. So according to KCL, it is IZ plus IY plus 5 equal to IX plus 3. In the first question, it is given that is 2 ampere, alright, and IZ is 0, which means there is no current coming from IZ. So if we just substitute here, so this implies that Ix is 4. In the second subdivision, it is given that Ix equal to 2 ampere and Iz is to Iy. Our job is to find Iy. Let me put a box around it so that we will be using it every time. So now let me substitute Iz as 2Iy. 2Iy plus 5 equal to Ix plus 3. And what is Ix? 2 ampere. So 2 plus 3 is 5. This implies that 3Iy plus 5 is equal to 5. Therefore, Iy will be 0 ampere. In the third subdivision, it is given that all the three currents Ix, Iy and Iz are same. In that case, what will be their values? If all three are same, let me put it as just I. and substitute I in the places of here, here and here. Therefore, I plus 5 is equal to I plus 3. This implies that I is equal to 3 minus 5 minus 2 ampere. So by applying KCL to the loop, we got an equation. Just by substituting the given values, we got the unknown values. Subscribe to my channel for more content on this. Every 2 or 3 days we will be uploading videos on circuits. You can solve with me during the video. You can post your questions in the comment, or if you have some topics to suggest me, let me know your views in the comment section.